Hey guys, welcome to Empty Stack and you are watching LeetCode series of problem solving using Java, and today we are going to look at intersection of two arrays. To solve this question, you should have knowledge on hash tables. The difficulty level is easy and this question was asked in 2 Sigma interview. Okay, let's jump into the question. Given two integer arrays nums1 and nums2, return an array of their intersection. Each element in the result must be unique and you may return the result in any order. Let's look at few examples. Example 1. Nums1 is 1, 2, 2 and 1. If nums2 is 2, 2. Now we see that if we do intersection of the two arrays, we see that 2, 2 is common between the two arrays. But it is said that the result must be unique. So the output would be 2. Example 2, 4, 9 and 5. Here in nums2 we see that 9 and 4 are present from first array, so 9 and 4 will be the output. And 4 and 9 is also accepted because the result can be in any order. If we look at the constraints, the length of the two arrays will be between 1 and 1000 and the values of the elements in these two arrays will be between 0 and 1000. Okay, let's look at the possible solutions. Approach 1, brute force. Let's take an example. Let's say we have two elements 9424 as nums1 and 4495 as nums2. Now what we can do? We can try and compare each element one by one, and whenever we find a match, we'll store it in a resultant array. Let's try this out. So let's say this is the resultant array. Now if we start with 9, we compare it with 4, it is not a match. We go to the next element 9 and 4, again it is not a match. We go to 9 and 9, now it's a match, we'll store it. Then we go to 9 and 5, it's not a match again. Now we move to the second element of the first array. Now 4 and 4 is a match, we'll store it. Then 4 and 4 again, it's a match, we'll store it. Then 4 and 9 and 4 and 5 will not match, then we'll move to the third element. Now 2 will again not match with any of these elements, so we'll move to the fourth element. Again 4 will match twice, so we can store them. And then we have this resultant array. Now again there is one problem, that the element in this resultant array are not unique. We have some duplicates. So we can perform another operation by iterating over this array, and whenever we find a duplicate we can remove them. Okay, so we'll have a resultant array that will have the unique values. So now we can conclude that we can find the solution if we compare each element from the first array to each element of the second array, and once we find a match, we'll store it in the resultant array. Now in the resultant array we will still have duplicates, so we can remove them to find the result. Let's talk about complexity of this solution. So comparing the elements would take O(n) square of time, because there will be a nested for loop to do the comparison, and to remove duplicates the complexity will be O(n), so overall complexity will become O(n) square. Now let's try to optimize this solution. We know that each of these input arrays has some duplicates, and in the result we are only interested in the unique elements. So what if we remove the duplicates beforehand? And for that we'll use a hash set. So let's say this is a hash set and we operate on the first input array and we try to insert the elements to a hash set. So the values that would be inserted would be 9, 4 and 2. The duplicate 4 would be removed, and then we would go to the second element, second array, and then we'll repeat the operation to try to store 4, 4, 9, 5. But while doing so, we can further optimize by only storing if the first hash set contains the value. So first we reach to 4. Now we'll check if it is present in the first hash set. If it is present, we'll store it. Next we go to the 4. Now again this is present in the first hash set, but it is already stored in this hash set as well, so we'll not store it because hash set cannot contain duplicates. Now we move to 9. Now 9 is also present in the first hash set, so we can proceed to insert it, and it is not found in the current hash set, so we'll store it. Moving forward, we try to store 5. Now 5 is not found in the first hash set, so we'll not store it. And that is it. We have found the pair which is unique and intersection of the two arrays. Now we can summarize this. We store the first array to a hash set to remove duplicates, and then we repeat the process for the second array, but this time we'll make sure that we'll only store to this hash set if it is found in the first hash set as well. Now let's talk about complexity. So storing and retrieving data from a hash set can be done in O(n) complexity. We need to iterate on both the arrays once, which will be overall complexity of O(n). Now let's quickly look at the Java solution. Now look at this function. nums1 and nums2 are the input integer array, and we need to return the intersection result in this integer array. So we'll start by defining the two hash sets, one for each input integer array, and then we will iterate over each of these input arrays and try to insert the value to the hash set. There is a catch. When iterating over the second hash set, like we discussed, we will make sure that the value we are iterating on is already present in the first hash set. Okay, if it is present, then we proceed to store it. Now the expected output is present in this hash set too, and we need to return in the integer array format, so we'll do so. So we'll create an result array of size of the hash set 2, and we'll iterate over it and return the result.